Hi, so today we're going to discuss on how to solve solutions to systems of linear equations using numerical methods. There are two ways on how to solve SLE, but we're gonna use Jacobi method in this one. The first thing we need to do is to check the given if they are diagonally arranged according to the highest x, y, and z variable. As we can see in the given, 8x, 9y, and 12z are the highest among all of the three equations with the x, y, and z variable. We are given here error less than or equal to 1% and the first three initial point as at 0, 0, 0. So now we're going to solve this equation by Jacobi method. The next thing we need to do is to find the value of x, y, and z by transposing all of the given to the right side of the equation. For the value of x, we have x is equals to 4 plus 3y minus 4z all over 8. And for the value of y, we have y is equals to 3 minus x plus 2z all over 9. And lastly, for the value of z, we have 2 minus 2x plus 6y all over 12. After we get the value of x, y, and z, we need to substitute the first three initial point to the given equation. Our first three initial point is 0, 0, 0. So we need to substitute them in here, here, and here to get the value of x, y, and z. Substituting the first initial value 0, 0, 0, we will get 4 plus 3, 0 minus 4, 0 all over 8 is equals to 4 over 8 or 0.5. And for the y, we have 3 minus 0 plus 2, 0 all over 9. We will get 3 over 9 or 0.33. And for the value of z, we have 2 minus 2, 0 plus 6, 0 all over 12. We will get 1 over 6 or this will be equivalent to 1.67. Now, we have value for the x, for the y, and for the z, and these three will be our initial point at 2. And this one, we will substitute it to the x, y, and z to get I3. And if we'll get I3, we will substitute again for the x, y, and z, and we will get I4. Then substitute again, we will get I5, and so on until we will satisfy the error at less than or equal to 1%. Substituting our new initial point at 2, x equals to 0.5, y is equals to 0.33, and z is equals to 1.67. If we substitute it to the value of x, we will get 0.53875. It's okay to consider all of the value to get the exact answer. And we substitute it to the value of y, we will get 0.315556. And lastly, substituting it to the value of y, we will get 0.248333. Now, we will have another set of initial point at I3, which is 0.53875, 0.31556, and 0.248333. Now, we will substitute it again to the value of x, y, and z to get I4. Then substituting again the value of I4 to the value of x, y, and z, we will get I5, and so on and so forth until we satisfy that the error is equal or less than 1%. Substituting the value of I3 to the given equation, if we will substitute the value of I3 to the equation x, we will get 0.494167. We will get in the y 0.3286 and 57. And lastly, for the value of z, 0.234653. Now, we have another initial point at 4, which are 0.494167, 0.328657, and 0.234653. Now, we will use this initial point to substitute for the value of x, y, and z, and we will get I5. Substituting initial point at 4 to the value of x, y, and z, we will get the value of I5. Then substituting I5 to the value of x, y, and z, we will get I6. And after that, we will solve for the error. The formula for the error is absolute value, current, minus rev, over current, multiply to 100, and we will get the value of error for x, y, and z. Computing for the error average, we'll just have to add the value of x, y, and z and divide it by 3 to get the error average. Solving for the error x, y, and z, substituting the value of the current minus rev over current times 100. For the error x, we'll have 0.234893, and for the error y, we have 0.142408, and lastly, for the error z, we have 0.779636. Now, we will solve for the error average, which equivalent if we add the value of this 3, divide by 3. And surely satisfied that the error is less than or equal to 1%. Substituting the value of x, y, and z, all over 3, we have 0.234893 plus 0.142408 plus 0.779636 all over 3. We have 0.39%, and it's satisfied that the error is less than 1%. So, that's how we solve Jacobi method.